So we're going to talk a lot about data in this little video, but before we do that, it's important to be able to separate between the two different kinds of data, qualitative and quantitative data. And I know it's cruel to students to have two words sounding so similar, meaning something different. But qualitative is something we can't count. It could be color of the shell of a mussel, it could be mating behavior of a goldfish, while quantitative is something we can count. Number of surviving offspring, weight of the shellfish. So it's important to be able to separate between these two when we get on to the rest of the chapter. So here I'm going to try to explain the scientific method just in a rough outline on how we're supposed to do science. And of course there's a lot more to it than this, but just to give you a broad outline. All science starts with observation. So I might be looking at my aquarium and I observe, in some of my aquariums there's a lot of algae growing, and in others aquarium that's not. So there must be something that causes algae growth. So that observation leads to a question. What can cause algae growth in my aquariums? Could it be nutrients? Could it be sunlight? Good questions. But to do science then, I need to come up with a hypothesis that I can test. Now we go into the science part. So my hypothesis might be that extra nutrients from fish feces will cause excessive algae growth. So that is my hypothesis, that if I have a lot of fish in a tank and they do defecate a lot, that will lead to more nutrients in the water, and that will lead to algae growth. So from my hypothesis here, then I have to design an experiment. I have to come up with an experiment to be able to test this. I have to figure out how to design it, how to have as many variables that I can control. We'll get into that later about independent and dependent variables. So I might decide, okay, I want to run with 3 aquariums, one with 1 fish, one with 10, and one with 20. And I might have to decide, what do I want to measure? Do I want to measure nitrate? Do I want to measure phosphorus? Do I want to measure something in the water while I do it? So now I designed my experiment, and then I have to test my hypothesis. So I have to do enough experiments so that I can be pretty sure that it's not just variables that I see and they're just random. And then I look at my results. And here comes the big part. For my results, how does this look on my hypothesis? Is it a yes, no, or maybe? And in most cases, this will lead me to reflect and then go back to my question. So it might be, okay, it seems to be that with more fish there was a larger algae growth, but my question should perhaps be, what nutrient causes the algae growth? Is it nitrogen? Is it phosphorus? What is it? Then go back and redo my hypothesis and keep running until I get more and more data. And it could also be that just get a big no. Nothing seems to happen. Then I might go back and reflect on why. Did I do something wrong? Is there something in my experiment design I need to look at again? But the important thing is that in science, what we really want to keep doing is try to look at our hypothesis, and we're actually trying to disprove it. We're actually trying to prove that our idea is not so, but every time we fail to disprove it, we go from a hypothesis and eventually it will become a theory if we keep being able to not disprove it. Okay, let's go a little more into detail about how to put on an experiment. So there are 3 words here that are important to learn when we talk about chapter 1 in marine science. That is the independent variable, the dependent variable, and the control group. And this often confuses people. So The independent variable, it's the one that we can change, and the dependent variable will be the one we measure. So how can this work out? Well, let's say that I want to do an experiment that shows how level of salinity in the water affect the growth of my coral. Okay, then my independent variable will be salinity level, because it's something I can change. I can add more or less salt to the water. And the dependent variable will then be coral growth. Or it could be that I want to see how light affects phytoplankton. So I have aquariums at different light intensity. In that case, the independent variable will be light intensity. The dependent variable will be the amount of algae growing, either measured by photometry or by weight or another way. And here comes the important thing. When we do an experiment, we need a control group. So a control group is a group where we don't change anything, because let's see I do an experiment to see how salinity affects survival of shrimp. I do it over like 3 weeks. So I have one with high salinity, one with low salinity, but I also need a control group, because if the shrimps die, anyway, in the control group, it shows me a lot about the data from the other groups. So it's very important that you always think about having a control group as well, a group where we don't change the independent variable, but we try to keep every other physical, chemical, environmental factor the same for the control group as same as for the other groups. All this here is of course a lot easier to do in the lab than out on the open ocean. So here's another example about how important it is with your control variables. Here I made kind of a rough sketch of an experiment where I have some blue mussels in 4 aquariums. I have a control group where I do nothing. I have the same amount of blue mussels in 3 other aquariums where I then add different amounts of microplastic. And my experiment might be to test if the amount of microplastic will affect the growth of the blue mussels. In this case here, it's really important to have a control group, because otherwise it's hard to tell if maybe they grew anyway or maybe they didn't grow anyway. So I need the control group to have something to hold my other data up against. But in this case here, I just want to see my independent variable being the amount of plastic, my dependent variable being growth of the blue mussels. I weight them before and after the experiment. It is then very, very important that I try to control every other variable, so that the temperature in each tank is the same, oxygen saturation is the same, amount of CO2, pH, and so on. Because if, for example, I put these in different places, so this one stands, close to the window, have a higher temperature than this one, we don't know if there's a difference between this one and this one. Did it come from the amount of plastic or from the difference in temperature? So we want to try to control every other variable, again, when we are in the lab, to make sure that we can make sure it's the independent variable that's giving us a change in dependent variable and not something else. So when you're thinking about, especially in Cambridge exam, how to design an experiment, always mention this, we want to keep temperature, CO2, pH, and so on the same for all groups, including the control group. And that's an easy way to get some points, so please remember that. So here we have an example from the exam last year, where they ask us to look at how substrate and barnacle settlement would affect each other, or how the substrate will affect barnacle settlement. And we are told here that the student chose 4 substrates: smooth granite, rough sandstone, loose sand, and smooth plastic. Then we have to state one hypothesis the student could test. And there are several ways to get the point here. One could be to say that more larvae settle on rough sandstone than on smoother surfaces. So that's one way to put a hypothesis up. You could also put up a hypothesis to say that very few or no larvae will settle on loose sand. Both of them would be good hypotheses. So for the next part of your exam paper here, we get what is very typical here of paper 2. We get a lot of text and information, and it's important to pay notice. We are told that seawater was placed in tanks, and the barnacle larvae of the same age, of the same species, were placed in the water in each tank. That phytoplankton was added to the water each day to provide food, and then the different substrates were added. And then each day the student removed the piece of substrate and counted the number of larvae that has settled on each piece. Then it was returned to the tanks in the same position each time. And the clever student here might notice something missing. That's true. There are no control variables. There's no control experiment here, which there probably should have been. But now let's look at the question Cambridge have to ask from this. So these shows the result after 10 days, and these are not very impressive results, which we'll get into later in the paper. But the question here is, state one variable that the student controlled in this investigation. And this is quite important, because there's actually quite a few that they can control. They have controlled the barnacle species. You can get a point for saying that. You can say they control the age of the larvae they put in. There's a point in that. They control the time in seawater. And we control the physical variables such as temperature, pH, and salinity. So all that can give you a point. And you can also go for the really obvious one, like the surface area and the size of the substrate you put in, the rough, plastic, and so on. That's also something that is controlled in this experiment. So there's many ways of getting this 1 point. So, as you might be able to see from the very small amount of larvae settled, the student could not reach a firm conclusion on the data. And Cambridge asked you to suggest 3 reasons why a firm conclusion could not be reached. And this is where you get a little more leeway on your answers, because there's many good answers here. One could be that the sample size was too small, that the amount of larvae who settled on this area was simply too small to see a difference. Another could be that we simply found too few of the larvae, that our way of spotting if the larvae have settled was not good enough. A third point could come from saying that we didn't repeat any of the experiments. It was only done once, so anonymous data could mean a lot. Another point could be that every time we take the sample up from the water, that might get the larvae to fall off or to die or be stressed, so that will have an effect on the data. Or you can say that, well, perhaps there was some uncontrolled variables that we didn't test. Maybe we didn't test pH or temperature, and if we didn't do that, that could explain the difference in the data. And the last question is, not surprisingly, suggest how the experimental method could have been improved. And again, there's many ways of getting the points here, but I will start by saying that we need to repeat the experiments, and we need to have more than one of each. So we don't just have one tank with sandstone and one tank with granite, but we have at least 3 of each. We need to have a control group, and then we need to explain how we want to do the experiment. And here's a lot of points to get from just stating the obvious. Well, same size of tank will get you a point, same volume of water, same temperature, that all the substrates in each tank should be of the same size area so we can compare them, that we add the same amount of barnacles to each tank, and that we add the same amount of food to each tank, and that we only examine the substrate at the end of the experiment, say after 2 weeks, 3 weeks, so we don't kill off the barnacles every time we touch the substrate. So many ways of getting the points here, but just try to describe the best way and go in detail on how you will control the variables, what variables you can control, and how you always want more than one tank and you want to repeat the experiment. If you don't have anything else to say, just say repeat the experiment 3 times. That'll always be a good answer in papers like these.